Today we are dealing with the chapter of fluid mechanics and physics. This chapter has a whole lot of very interesting questions which we will solve now. In this chapter you just have to be very careful about the tricks which I tell you. Use them and it will help you. So in this question we first begin with, there is a block, cubical block of h 3 centimeters, and the lower surface of the block just touches this spring when it is floating in water. This is water. Now we need to find out what is the maximum weight that can be put on this block such that this block does not sink totally in the water. So for going about this question, let us see how much of this block is already inside the water initially. So for that, we know that for a floating body, the downward force acting on the body is rho of the object into the volume of the object into g. This is nothing else but the weight of the object, that is mg. The buoyant force acting on the object is equal to rho of the liquid into volume submerged into g. The buoyant force is always equal to the density of the liquid into the volume submerged into g, and it is always perpendicular to the surface and directed outwards. Now we balance these two to get rho liquid into v submerged into g is equal to rho of the object into v of the object into g. The g cancels and we get v submerged is equal to rho object upon rho liquid into volume of the whole object. This is an important formula you should remember, and this is the case whenever the object is floating in the liquid, whether the liquid be in any situation. This is always true. Now if the density of the object is less than the density of the liquid, the volume submerged will be less than the volume of the object, that is, the object will be floating in the liquid, otherwise the object will sink in the liquid. Now you are using this formula, we have the volume submerged, we can write height submerged is equal to density of the object upon density of the liquid, that is specific is equal to the specific gravity of the substance, that is rho object upon rho liquid, the specific gravity of the object relative to the liquid in which the object is. Over here the liquid is water, so we call it the specific gravity of the substance, that is equal to 800 divided by 1000, that is the density of water, that is 0.8 into the height of the object, that is 3 centimeters, that is equal to 2.4 centimeters. So 2.4 centimeters of the object is already inside water. Now we want that this block not to sink totally in the water, and the limiting case in which the maximum weight, when we put the maximum weight on this object, this block just sinks by 3 centimeters. So final condition will be, the block is like this, 3 centimeters inside water, there is some compression of the spring, the compression in the spring will be equal to 0.6 centimeters because this block went down by 0.6 centimeters. So the force acting in the upward direction on the object will be equal to 50 into 0.6 upon 100 kx, that is equal to 0.3 newtons. This is kx. The mg below will be equal to, and there will be a buoyant force. Now the weight kept is W, which is the maximum weight. There will also be a buoyant force acting on this object, that will be equal to rho liquid, that is 1000, into V submerged, that is 27 into 10 raised to the minus 6 meters cube into G. Let us calculate the buoyant force first and the weight additional W. We can write this equation as W plus mg is equal to 0.3 plus rho liquid into V submerged into G. Let us calculate mg first. The mass of the object is equal to the density into the volume, that is 800 into volume is 27 into 10 raised to minus 6 meters cube. This is the mass of the object multiplied by 10. So this gives us the weight of the object, that is equal to 0.22 newtons. So we substitute 0.22 over here. 0.22 is equal to 0.3 plus rho liquid V submerged into G. Let us calculate this quantity now. Rho liquid is equal to 1000. V submerged is 27 into 10 raised to minus 6 meters cube and G is 10. So this gives us the value to be 0.27 newtons. So we substitute 0.27 newtons over here. So final answer becomes 0.05 plus 0.3, 0.35 newtons. So final answer for the weight, that is maximum weight, which can be kept on this block so that it just doesn't sink completely, is equal to 0.35 newtons. In this question you should have remembered one thing, that the submerged volume of the object can be found by the ratio of the density of the object and the liquid.